In this video series, we'll talk a little bit about properties of exponents, which is really important. Now remember that an exponent is, another way of thinking about an exponent is the power. So let me make this 3 raised to the second power. So this means 3 raised to the second power. And sometimes people say 3 squared. This guy here is called the exponent, and the 3 is often called the base. So an exponent, recall, tells us how many times to multiply the base by itself. So that's what an exponent tells us. So in this case, 3 squared means take the base and multiply it by itself 2 times. So 3 times 3 would give us an answer of 9. So that's what an exponent is, and so we're pretty familiar with that, of course, but just as a little review. So properties of exponents, really important. So let's just say, now this isn't always the most fun or exciting thing to do, but sometimes it's helpful to understand exponents by kind of going through a few examples and simplifying. So for instance, let's just say that we have the following we call expression. So 2 times x to the third power plus 3x squared plus 4x plus 9. And we want to simplify, so combine like terms. Okay, well, what are like terms? Well, like terms are any pieces. Now remember, this is 1 term, 2 terms, 3 terms, 4 terms. So there are 4 terms here. And in order for us to be able to combine them, now we're combining them via addition in this situation, I have to have exactly the same things. So in other words, here I have 2 copies of an x to the third power. So the thing that I have 2 copies of is the x to the third power. So basically I have x to the third power, I have 1 of them, and then I have another one. So I have 2 x to the third powers. Here I have 3 x squareds. Here I have 4 x's. And here I have a 9, so I just have a whole number. Well, in order for me to be able to combine things, they need to be like. So for example, here we're talking about apples, here we're talking about oranges, here we're talking about bananas, and here we're talking about something, just a constant value. So how could I possibly combine apples and oranges and say what a lot of people want to say, which is, oh, does this mean I have 5x to the fifths? Well, not only have you changed the quantity, not only have you combined these 5 things, but you've also called them something else. So you've said that having 2 apples and 3 oranges produces 5 or apples or oranges or something like that. So we can't really combine that way because we're not combining like things. So that's the way I like to think about it. No memorization of rules, but the bottom line is that we need to be able to combine like things. So our final answer would be 2x to the third plus 3x squareds plus 4 x's plus 9 ones. So 9 constants. Okay, so what about another one? Well, let's just say that we have x to the third plus 3x to the third plus 4x plus 9x to the third. Okay, well, let's see, what do I have common copies of? Well, I have just 1 x to the third here. I have 3 x to the thirds here. I have 9 more x to the thirds over here. So how many x to the thirds do I have? Well, I have 4 plus 9 is 13 x to the thirds, and I have 4 x's, and I can't combine those with x to the thirds because it's like adding apples and oranges, and that just doesn't make sense to say I have 17. Well, you can say pieces of fruit, but we don't really want to do that. We don't want to make things homogenized, make them the same. So same thing would apply regardless of what type of example we have. So if we're adding 3x squared plus 9y plus 9y squared plus 13x squared, well, I want to find things that I have common copies of, or that I have copies of one common thing. So I have 3x squareds over here, and you might say, well, oh, there are 9y squareds over here, but we're not comparing the apples to apples. We have 9y squareds, and I have 3x squareds. Those aren't the same thing. But then over here I have 13 more copies of x squared, and I have 3 copies of